Very much, and thanks so much for the opportunity to present both our work and as well as my personal story. So I'm going to bring those two kind of intertwined perspectives today. So as a mom of a 17-year-old with Duchenne muscular dystrophy, who started participating in clinical trials at 8 years old, as my work in Casimir on research. Next slide, please. So when I look back on the ways that clinical trials have unfolded in Duchenne over the past decade, I think that my son's generation of boys have really been let down on two fronts, both what's been asked of them in their clinical trial participation and the definitiveness of the answers that have come from all those efforts. And on that second point, I'm referring to the outcome measures used to collect that data, as well as the disconnect between design intentions and the reality of the way that data is collected. So, for example, from my personal history, a story might say, we're going to standardize our data collection by requiring that every patient is assessed at 8 in the morning. And that way we'll know that every patient is assessed at the same time of day across the entire study. And they just don't realize that, when you're bringing your child in from the West Coast, that he's doing his physio testing at 5 in the morning. Next slide, please. So it's explained to me many times that FDA approves drugs based on how patients feel, function, and survive in their daily lives. Next slide, please. But in my son's first clinical trial, the assessment of how he felt, functioned, and survived in his daily life was done by flying him first to a different country every Wednesday. He spent the day in clinic assessed by people that were unfamiliar to him. That became a problem when he unnecessarily dropped 60 meters in the 6-minute walk one assessment because he was trying out a track and field racing strategy to try and get his best performance. We only figured this out because study policy was violated by involving me as a parent and trying to figure out what had happened. The stakes were really high because an additional muscle biopsy had been added to all boys that declined. And his previous biopsies had led to a tightness in his right leg that persists to this day and hinders his ability to walk. And his function was assessed by an outcome measure that was really designed to measure exercise capacity. As he would always say to me, why do they think I want to speed walk so much? I just want to walk around school. And so the bottom line is that the trial was not particularly successful in assessing how he felt or functioned in his daily life. Next slide, please. With the emergence of COVID, the field has pivoted rapidly towards converting clinical outcomes to remote capture. In doing so, that has addressed a huge concern of mine, and I think of most rare disease patients who participate in clinical trials, and a patient burden, which is fantastic. And I hope continues far beyond the resolution of COVID. But I think that there's a tendency to declare mission accomplished and to avoid thinking of the other aspects of clinical trial participation that are problematic for us as a community. Next slide, please. This next slide lists the studies in Duchenne that have failed to reach statistical significance on their primary outcome or have failed to reach definitive data in the last decade. And so for many of these studies, we don't have definitive answers on whether it was the treatment being studied that was the issue or the study design itself that failed. And this slide really represents over 1,000 families like mine who gave their time, effort, literal blood and flesh in search of answers that never came. Next slide, please. So in an effort to address this ambiguity, we started developing the Duchenne video assessments far before the emergence of COVID, but it's ended up being a solution that really addresses this specific situation. So in the goals for the DVA, we wanted to make sure that we were designing an outcome that tried to understand the patient's trajectory at the time of treatment administration and to quantify the trajectory from there. We're doing that by taking a look at ease of movement as a concept of interest rather than speed of movement. And we do that by counting these compensatory movement patterns that patients adopt to work around progressive weakness. A lot of times the boys don't even know that they're adopting them. They're just doing what they need to do to maintain their current degree of independence, which makes them a nice thing to quantify that's less confounded by motivational factors. We wanted to make sure that we quantified nuanced enough compensatory compensatory movement patterns that allowed us to be sensitive over a relatively short duration of time, and yet only quantify the compensations that represented a clinically meaningful amount of disease progression. And then we wanted to allow for different compensatory strategies. So when a boy with Duchenne gets off the floor, some of them will walk their hands along the floor, but not push their hands off their thighs. Some of them will do the opposite. And so we wanted to have a kind of straightforward method for quantifying these compensatory strategies that didn't force these compensations into a spectrum that may be potentially arbitrary. Next slide, please. So the way that it works is we have a menu of 17 tasks. Those span the entire progression of Duchenne, from the very younger, stronger boys to the more progressed, older boys. So any individual patient will probably take only 4 to 5 videos. We have a set of training videos that standardize the video capture. You know, people have mentioned the importance of standardization, and so we've standardized the capture procedures with these training videos that show parents how to do this themselves. They download an app, a mobile app that's both HIPAA and GDPR compliant. We can localize it to a number of different languages. And then the caregivers record their children performing these daily tasks using this mobile app. We have a quality control check on the back end that makes sure that each video has met the success criteria that's been predefined for each video. We send back anything that doesn't meet that success criteria for a reshoot. And then we have a certification program where we've trained physical therapists as central raters, and they go ahead and quantify what they see on videos with this validated scorecard. We have a dashboard that allows us to present those videos to them. The PTs can, fast forward, slow motion, freeze frame, frame advance, all they need to do to get a really definitive idea of how patients are appearing as they're doing their assessment. And then we look at change over time for an individual patient. So we're not just comparing one patient to the other. At each time point, we're comparing the rate of change for patients over time to see basically if a treated arm is acquiring these compensations at a slower rate than the control arm. Next slide, please. So this is an example of how this works in reality. Hopefully this video will play. Can you go ahead and try and play it? Okay, so it looks like maybe there's a codec missing from the computer that's displaying it. So the way it works, we have a patient that is getting off the floor from a cross-legged position at time point 1, and then again at time point 3. So if you move to the next slide, I'll be able to show you how that's quantified. Next slide, please. So unfortunately, if you're able to see this, the types of compensations that we're taking a look at, we're looking at his base of support. So it's gone from slightly wider than shoulder width to markedly wider than shoulder width. At the baseline, he doesn't walk his hands along the floor to lift his trunk. And then at the second time point, he does so. And then at the first time point, he does not push his hands off his thighs to straighten his torso. At the second time point, he pushes one hand. Now, it's unfortunate that you can't watch that video, because every time I play that video for anyone, even without a Duchenne background or without a physical therapist background, they're able to articulate that it is getting much more difficult for him at the second time point. So we're looking at a rapidly increased severity percentage for this child over time. And this is, like I said, within a 30-week period, which is much shorter than the typical duration of a clinical trial in Duchenne, which is 48 weeks. Next slide, please. So we did take a look at our inter-rater reliability and intra-rater reliability. Anytime that you're going for increased sensitivity on an outcome measure, this is always a concern. So we were really excited to see that 12 out of our 17 tasks scored an ICC of 0.90 or higher, which was really exciting to us, that we can do this, this type of remote assessment in a way that's really sensitive and reliable at the same time. Next slide, please. And this is our intra-rater reliability. Again, equally high, 15 out of 17 tasks scored an ICC of 0.90 or higher in the Duchenne specialist. So we were thrilled that the reliability came out as high as it did. Next slide, please. We also took a look at our construct validity. So we had DMD clinicians stratify groups, the videos into 5 different groups, ranging from no weakness to not the inability to complete the task. And we saw statistically significant differences in our severity percentages as we moved through those 17 movement tasks. Next slide. So our next steps for this outcome are to take a look at our instrument variability. Our hope is that it's going to be pretty low, just because these boys really do tend to adopt a pattern and stick with it until they have enough disease progression that requires them to adopt an additional compensation. And then we're also taking a look at its applicability to other diseases. We're midway through validation in primary mitochondrial myopathy in limb girdle, and taking a look at Becker and SMA as well. Next slide, please. So just a few pieces in terms of lessons learned. I think that there is sometimes a temptation when tech like this, like the app that we have, gets added to a clinical trial. And in our experience so far, we get much higher rates of compliance and retention when we actually continue that human contact with a study coordinator. So we have a staff of study coordinators that are trained in remote data capture, and they form relationships with these patients, and that really can't be underestimated in minimizing any missing data. Second is that, I think sometimes, people adopt a particular piece of tech and they consider that the outcome measure, but the tech is really the tool. The outcome measure is the concept of interest. And so really making sure that these outcome measures are concepts of interest that are meaningful to the patients, to their daily quality of life, is critically important. And as I spoke about, understanding the trajectories is critical. And then lastly, for us, maintaining and building a system that allows us to maintain a complete audit trail is critical. When a patient submits a video, if it fails that success criteria, we keep all copies of those videos that are submitted and we document the reason why a reshoot was required. Next slide, please. So in closing, I just wanted to circle back to the fact that it's really gratifying to see all of the ways in which COVID mitigation strategies are addressing factors that help rare disease families both access research and access care. But my hope is that in despite of the success of those strategies, that we as a rare disease community can maintain focus on a solution that addresses the totality of the issues that we face, and not just this piece of bringing assessment into the home. And then I would be remiss in not thanking the parties that have helped us both with funding and with guidance as we develop this outcome. Thanks very much.